Find the answers to questions you may or may not have asked yourself here at Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palmer and Sönke Löw. I often cannot remember my dreams, but when I do, they usually are somehow responding to things that have happened in my everyday life or in the past. In general, it is thought that dreams play an important role in processing things that happen in our awake life. However, I personally often rather remember confusing or stirring dreams rather than pleasant ones.
To dive more into that topic, we have, as always, invited an expert on this field. We'd like to welcome Jona Lemke. You wrote your bachelor thesis on emotion regulation during dreams, is that correct?
Yes, that's correct. And as always, we want to play a short get-to-know game to introduce our guest to all our listeners and to kind of get a feeling of what kind of person you are. In this game, we give you the beginning of 5 different sentences, and we ask you to finish those sentences.
Mm-hmm.
Are you ready for it?
I'm ready.
Perfect. Okay, the first sentence is, as a kid, I always wanted to be.
I wanted to be an author, I think.
Did that change over time, or?
Yes. Then after some time, I realized that I don't want writing to be my profession because it's difficult. It's a difficult career, and I don't want to sort of have this hobby or passion of mine turn into something professional. I want to preserve it as a hobby or something I enjoy.
Yeah, and I think it can be really challenging to do that when you have to get money out of it, right?
Yeah, exactly.
Yeah. If I was an emoji, I would be.
I would be the one who's smiling a bit and has like this angel halo over it. I really like that one.
My favorite thing to do on a day off is?
Reading, listening to music, going for a walk. These kind of things. Also playing computer games sometimes.
That sounds good. Right now, I'm most fascinated by?
I'm recently really fascinated by GeoGuessr, a browser game where you have to guess your location on Google Street View based on the Google Street View images you see. And somehow I got really into this because I find it a fascinating concept to find out what location on the world it is and how different places of the world look like.
Yeah, I can imagine that's quite challenging because I would consider that some regions of the world look quite similar, while others are really different to other regions, but in itself look quite similar when you are in one specific part of the world.
Yeah, and it's also, it's just really fascinating how different climate zones also look like, or how the south of South America after some time looks like Norway a bit, because there are also mountains, and if you go more towards the South Pole, the climate becomes cooler again.
Yeah.
And it's really fascinating to me.
I can imagine. I know it's time to call it a day when?
When I'm noticing that I'm just getting really tired and fatigued, I guess. And for example, when I'm working on something and I'm sitting 5 minutes on one sentence, or I read and I have to read the same sentence or passage over and over again because I cannot concentrate anymore.
So in a way, when the brain stops working.
Yeah, exactly.
So now we have a bit of an idea of who you are, and from your scientific side, you have done your bachelor's thesis at the University of Osnabrück. What were your main fields of interest during your bachelor's?
During my bachelor's, things have changed actually, because earlier in my studies I was more focusing on philosophy courses, philosophy seminars. But then, yeah, I have done different, like I have focused on different things. I did my oral exam in neuroinformatics, so for some time I got really into that to prepare for that exam again. But mostly it has been neuropsychology and philosophy. And yeah, also like for quite some time then sleep and dream research. And I finally wrote my bachelor thesis also about this field of cognitive science.
Mm-hmm. Is dream or sleep research something you want to do afterwards, or do you have different plans for after your bachelor's?
I can imagine to follow that more during my further life after this bachelor's. Yeah, because I want to do my master in cognitive affective neuroscience, so also like a neuroscience, neuropsychology master. And I would say I'm not like hyper focused on this field of research. I don't want to pursue this research at all costs or something later. But I would really like to do more research in that field. Yeah.
Interesting.
We have heard that you did a lot of sleep and dream seminars during your bachelor's here, and you also wrote your bachelor thesis in that direction. But I'm assuming like the research field is quite vast. So you have a particular interest in the emotional side of the sleep, or how did you come up with your topic? And maybe can you give a brief overview what the topic was about?
Sure. Yeah, you're right. Sleep and dream research is quite a vast field, and I learned that especially sleep is better researched than dreams. And yes, like dreams have always like fascinated me more in this field. And for example, in one course, Introduction to Sleep and Dreams, I did a presentation about the function of dreams, and I found that really fascinating to get into that. And so yes, then I approached, so the topic of my thesis was not something I came up with straight away, but I just approached my supervisor, who was also teaching that course I just mentioned, and who's really into sleep and dream research at our university. So Katharina Lüth, she's also leading, or one of the leading persons of the Sleep and Dream Student Initiative of Cognitive Science. And so I just wrote her an email and said, hey, I would really like to write my bachelor thesis in some sleep and dream related research, and more specifically I could imagine doing something on naps, because I also really like naps, and I'm like fascinated how little time of sleeping can have really huge benefits for you. And also it's easier to do a nap study than a full night of sleep study. Yeah, and so I also said I want to do something practical. If possible, I want to conduct an experiment. And then she said, yeah, sure, perfect. And then we talked about it, and then she came up with the specific topic of emotion regulation, theory of dreams and dreaming, and told me, yeah, her research idea that she would really like to try to confirm how dreaming and dream content specifically can have a benefit in emotion regulation. And so, yeah, we kind of came up with the idea together. And so the more narrow topic of my bachelor thesis is emotion regulation of dreams during a nap. So during a 2-hour nap opportunity. Yes.
When you said nap, I first thought about like power naps, which would for me last about 15 to 30 minutes. You now said that the nap in your experiment lasted for 2 hours. Why did you decide to do such a long episode of sleeping?
Yeah, you're right. So, like, a nap is technically considered to be only up to 30 minutes. We mainly did such a long period because we wanted to investigate dreams, and we know that another person of the Sleep and Dream Initiative, they conducted a nap study with only 20 minutes of sleep, and in this study no one reached deeper phases of sleep and no one had REM sleep. So because especially in like a laboratory environment, it often takes a long time for people to fall asleep. Mm-hmm. And we specifically wanted them to dream. Yes. And and also like the other studies I read for my research, they mainly all had 90 minutes at least, 90 to 100, 120 minutes of sleep. So we adapted that.
You already quite jumped a bit into sleep terms. So you just mentioned REM sleep, for example.
Yeah.
And also other sleep stages. So could you maybe just shortly explain us how sleep usually looks like? So we have different sleep stages. What sleep stages do we have, and how far, or which one is the most interesting for dreaming especially?
Yes, there are different sleep stages. We have mainly 3 sleep stages, N1, N2, and N3. Formerly there had been a 4th N4, but it got reduced to N3 some time ago, and we have REM sleep. So N1 is the lightest stage of sleep. It's also when you fall asleep and are still kind of conscious. N2 is when you're already sleeping, and N3 is deep sleep. So it's the deepest stage, and it's really like, you're really off. And if someone awakes you in that stage, it feels really uncomfortable because you have to take some time to get like awake again. And then we have REM sleep, which is also a really light stage of sleep. So it's like also brain-wise really close to being awake. Mm-hmm. And it's called REM because it's an abbreviation for rapid eye movement. And in this sleep stage, the sleep stage is particularly characterized by really fast movements of the eye that last for a few seconds. And you can see that, so the eyes are closed of the people sleeping, but you can see their eyes moving really fast from left to right. And that is the sleep stage that is like traditionally associated with dreaming. Dreaming can happen in all sleep stages, but most of the dreams happen in REM sleep. And also REM sleep dreams are the dreams we usually remember that are really emotional, vivid, in nature, that have like a story that is told or something. And we also remember these dreams better than the deeper sleep stage dreams, because REM sleep is the sleep phase that is like that you are in just before you awake. So usually you wake, like if you awake naturally, you wake up from REM sleep, and then you just had a dream, and you can remember that dream best because it just happened. And
yes. Usually
you have a difficult time remembering dreams that happened a few hours ago during sleep.
And during sleep, do we go through one of those cycles of N1 to N3 and then REM, or do we have multiple cycles?
Yeah, during one night of sleep, you go through multiple cycles. So exactly. You go from N1 to N2 to N3, and then back again to REM. And so REM is always at the end of a sleep cycle, and these cycles last about 1.5 hours. It's a bit different from person to person, but this is the average. And depending on how long you sleep, you go through multiple cycles. So, for example, if you sleep 7.5 hours, you have 4 of these cycles.
Okay, yeah.
Yeah.
You mentioned that dreams during REM sleep are especially loaded with emotions. Is there maybe, or are there several theories on why we dream at all, or is there a definitive answer to that? Do you know that?
No, there's not a definitive answer to that. There are many theories why we dream. In fact, like Katharina Lüth, my supervisor, also offers a seminar now that is just called Why We Dream. So that alone suggests that there are really different theories, and it's not clear which one is true. It is generally dreams are generally considered to help us with emotional processing, with dealing with our emotions, with coming up with new ideas and perspectives on our waking life. But scientifically, it's really not researched that well. There are also theories saying that dreaming prepares us for a waking life in the form that, for example, there's the social simulation theory that suggests that dreaming prepares us for our social life in the wake by simulating different social situations. There's also the threat simulation theory, it's called, I think, that says like a similar thing, but with threats, so that during dreams we practice dealing with threatening situations so that we can adapt better in wake. But ultimately there are many theories, and there's definitely more research to be done because we actually don't know so much about the function of dreams, and it has been a mystery for a long time. And there's also many researchers who argue like, oh, well, if dreams are so important, why do so many people forget them? There are also people who never remember their dreams, so what good does it to them? And then it's also unclear if dreaming benefits us all, because actually every person dreams, also the ones that don't remember their dreams. So it's also unclear if they also benefit from dreaming if they can't remember their dreams. So if like the process of dreaming alone is helpful, or if you have to remember them. And so there are a lot of open questions.
I've heard that one of the theories why we dream is to process emotions. That's also what you try to find out in your bachelor's thesis. What's the state of research on the question of emotion regulation and dreams?
The state of research is not that far. I like during the research for my bachelor thesis, I got the impression that there are like 2 sides of dream research. One that is more psychologically, so like by psychology researchers that deal with the content of dreams, and the other one is more neuroscientific, if you can say so, like more by neurobiologists or neuroscientists who look more at the EEG correlates, for example, so like the EEG signature that is present in our brain while we dream. And I think that's also maybe a shortcoming of dream research, that dreams are approached in very different ways. And in fact, I only mainly found one researcher who really did longitudinal studies on emotional processing and emotion regulation of dreams, Rosalind Cartwright, and she already did these studies like quite some time ago in the end of the 80s, I think. And so she really looked at people who had depression and how dreaming offers stressors. So she did like studies with people going through a divorce, and she looked at how dreaming of the ex-spouse or the person you are divorcing from helps you adapt in the long term. So she did a checkup after 1 year. And yeah, she could show that people who dreamt of the stressor of their ex really were better off and had significantly less depression after 1 year. But she was really the only person I found who did this kind of research, and others did more like very short-term research, so studies that only lasted 1 night, typically, and very few looked at dream content, and yeah.
I think I imagine that it can also be hard to really estimate in how far people dreamt of the ex in this example, because when a person can't remember their dreams that well, when you can ask them, did you dream of your ex, but they can't really answer that properly, because if they don't remember, they wouldn't say, yes, of course I did. They would just be like, I don't know, I guess. Did she only include individuals that remembered their dreams but were not dreaming of the ex, or did she also include people who just did not remember their dreams? Do you know that?
I think she did include people who did not remember their dreams. But yeah, exactly, that's like the difficult question I also mentioned before, that you don't really know if people also benefited, if they don't dream or can't remember their dreams. Sorry, what?
My question was if you are aware if she kind of differentiated between people who remember their dreams but did not dream of the ex, and people who could not remember their dreams at all.
I think she did different. Yes, she definitely included people who dreamt but didn't dream of their ex.
Mm-hmm.
And yeah, I think she included all these groups for analysis. Yeah.
Are there any tools that a researcher could use, like to help the participants to remember their dreams? Is there like special tactics or strategies that you can apply in order to make sure that most of your participants are able to recall their dreams?
Yes. So the main technique for remembering your dreams or helping dream recall is practicing writing down your dreams or recording them after you wake up. So kind of dream journaling. It doesn't have to be on paper. As I said, you can also record your dreams via audio. And if you practice that, the success rates are really high. So if you try to do that every day, or at the beginning, every time you remember something of your dream, your dream recall will really improve over the next days and weeks. It may take some time, of course, but that is a really efficient way to help you remember your dreams better. Otherwise, if you're in the situation that you're a sleep researcher and you want your participants to remember the dreams well, there are not so many things you can do, I guess, but there are certain details. For example, if you wake up your participants more fast and abrupt, they will remember their dreams better. Or if you come in and have an audio recording device ready and ask, what did you dream? People can just start to talk right away. And if they have to write it down, it's like not as fast, so probably you will forget some things while you write it down, and if you talk, that's a quicker way of recording. So yeah, there are like certain details you can change in the recording of the dream. Yeah.
Do people usually rather remember pleasant dreams or unpleasant dreams?
Unpleasant dreams are generally remembered a bit better, and there are also many researchers who suggest that, in fact, we do dream with negative emotions or have like somehow negative dreams more often than positive ones. So that is also maybe a hint that dreaming is so important in emotional processing, because we tend to reflect on negative things that happen to us, or negative emotions we are feeling right now in our dreams. And also the emotional intensity of the dream also predicts dream recall. So like the more emotionally intense, and also the more this emotion is like connected to you, or this dream content is relevant to you personally, the better you will remember your dream.
So in a way, importance strengthens recall.
Yes, definitely.
We talked a bit about the emotional processing side, but is there any measurement? So how do researchers find out if we do like emotional processing? How do we really measure that? You already hinted at that study with the people who were going through a divorce, but what is like maybe a more short-term way of measuring the emotional effects of dreaming?
There are different measurements you can do. Some researchers also use physiological measurements.
What would those be, for example?
Actually, these would be like skin conductance rate or heart deceleration, but actually these are not like immediately connected to dreams, but rather to, for example, I read a lot of research about people seeing negative stimuli, so negative pictures, for example. That's also what we did in our study, before and after sleep. And then you can use these physiological measurements to measure the emotional reaction while the people see the stimuli, the pictures, for example. And you do that before and after sleep or dreaming. But in this sense, it's not physiologically immediately connected to or like happening during the dreaming. Otherwise, you can, of course, record the dreams and then like analyze the dream content, and in this way see how like what emotions were present in the dream reported, or what the content was, and you can kind of analyze this for emotional processing. For example, the researcher I mentioned before, who was doing the divorce studies, took like had like her participants write down current concerns, like I don't know, financial concerns, different things that occupy you in your waking life, of course related to your ex-spouse in this example, and then you can analyze the dream and look at how, like, for example, how many times did the ex appear in the dream, what concerns appeared in the dream as well, and then you can like draw connections to the waking life of the person.
When we talk about our dreams, especially when it's clearly connected to something that has happened, so for example, dreaming of the ex-partner, it's quite obvious that it reveals something about ourselves in a way. Is that also the case when we dream of things that are more abstract, or kind of, is there any research on in how far our dreams might also reveal us information about what our underlying or what our unconscious parts are dealing with?
Good question. I don't actually know if there's research really looking at this, but it would be really interesting. Would also maybe be hard because how do you specify the abstract? What I can say, for example, what I also found interesting was that Rosalind Cartwright, again, like the person doing the divorce studies, also looked at, in one study, looked at what context the dream content has. So how the X, for example, is connected to other memories or other, stuff that is going on in your life. And she also took that as a measure how well your trauma or difficulty you're dealing with is like woven in sort of into your other memory or how your broader network. And I found that also really interesting because in fact, like the better the specific stressor was like connected to other parts of your memory network, the better you also were off later, so the better the remission from depression was.
That sounds a bit like the whole dreaming and emotion regulation is also connected to memory. And how far is that the case?
Yeah, that is definitely the case. Many researchers point out that a key function of dreaming actually may be connecting recent events with older events of our memory, because we all know that when we dream, memories from really far behind, from years ago, can pop up suddenly. Places that we haven't seen for years can pop up. And just like sleeping also is helping you learn and helping you integrate stuff that you recently learned better in your whole network of things you know. Dreaming may be necessary to connect things that you recently dealt with or experienced better in your more broad network of memories and things you already have experienced. And actually also neuroscience supports that thesis because when we dream, also like more distant memory networks can communicate or do communicate.
How can they see or how do they know that they communicate?
Well, that is I think they measure that with EEG. So the theta oscillations of EEG, so that's a specific EEG signature. I don't know exactly how they measure that, but I guess with like fMRI or some image-related measurement, they showed that like parts of your brain which are somehow further apart, or memory networks that are not immediately connected or usually not communicating during wake do communicate, are active during dreams.
Just a quick information, maybe like if people listen and they don't know what EEG and fMRI is, so that's basically the way I understand it is an imaging technique to measure like the activity in a certain brain region, and then we have certain brain regions associated with certain functions, and so we can maybe from those images conclude some information about the person's consciousness or mental state.
And in EEG, for example, you measure the electrical signals your neurons fire, and in fMRI, you measure the magnetic activation in certain brain regions. And in EEG, you get it looks a bit like it looks like lots of ups and downs. So you also mentioned theta waves, which are one of the, I think, 5. Are there 5 different brain waves?
Yeah, I think so. Like alpha, beta,
gamma, delta, theta. Yeah, it should be 5.
Yeah, I think so too.
So it's one of the 5 patterns in which our brain waves usually are shown on an EEG. And in an fMRI, those are the pictures where you kind of see, or when you get fMRI pictures and you look at them, you get brain regions which are really active in a certain color. So they are usually colored red when they're active,
exactly.
and blue when they're inactive.
Mm-hmm.
And when you look at the pictures in the end, you kind of get an idea of which brain regions were more active during one certain part. Coming back to the topic of remembering dreams and memory processing and memory formation, I think I've once read a study where it was a mouse study, where they had mice running through a maze and measured the brain activity during this exercise, and also measured the brain activity during sleep. And what they found there was that the mice dreamt that similar brain regions were active during dreaming as during running through the maze, and that after they have dreamt after they have had similar brain activation patterns, they were better performing in the maze task. So of course we can't ask the mouse, well, what did you dream last night? That's a bit difficult, but I think this also speaks for the idea that when we dream of something that has happened, we might be better able to recall our memory afterwards.
I also know the study, and that's also like a theory about dreaming, that you learn during dreams, and you often dream about a task that you did for a long time during the day. So, for example, if you played a certain computer game for hours during the day, or you try to solve a certain coding problem for hours, it's likely that this will appear in your dreams. And so for the mouse, it also ran, 4 hours through this maze in wake, and then it dreamed of the maze. But the interesting thing is that we never have a mere replay of the things we did during wake, but it's already an abstraction. So, for example, if you played Tetris on your computer for hours during the day, maybe you will dream of the shapes of the blocks, but I don't know, like in 3 dimensions, or somehow you can't control them like you can in a computer game or something like that. And actually, like one theory about why we dream, which I really like, is the overfitted brain hypothesis. I have to explain overfitting. So overfitting means is a term of that comes from machine learning, and it means when you try to model something, so you have a lot of data points and you try to fit a certain curve to that sort of explains the data points. For example, like a parable. You have the problem. You can have the problem if you try to fit too many data points. You will overfit the data, and if you try to fit the curve to too little data points, you have underfitting. That means that you have either like a curve that is too detailed for it to really abstract, that is overfitting, or you have a curve that is has too little detail, that is underfitting.
Yeah, so in other terms, overfitting happens when you, for example, when an algorithm, because this comes from machine learning, so when an algorithm always only sees red dogs or let's just say ginger cats, always just sees ginger cats, and then the algorithm for some reason learns, okay, cats are always ginger cats. And then when you show it a black cat, which was not in the data set, it learned the pattern from, it won't kind of recognize that the black cat is also a cat because it only learned that cats have ginger-colored fur, but kind of assumes that a black cat can't be a cat.
Exactly. Very good example. Yeah, and overfitting is a real problem because you try to fit everything and therefore lose the abstraction, lose the bigger picture, so to say. And if we adapt this to the human brain, this overfitting brain hypothesis says that especially when we are learning something and we are dealing with that for hours during the day, we have the danger of overfitting. We have the danger of being too specific and sort of not see the bigger picture and not be able to generalize what we learned in order to also adapt this theory to new inputs, like the black cat in your example. And so this hypothesis says that dreaming is exactly so bizarre in nature and so weird and abstract in order to reduce overfitting, in order to generalize better what we have learned. And I really like this hypothesis. And
So kind of when you have only seen as a human being, for example, or when a child has only seen ginger cats because maybe the family has 5 cats and all have gingered fur, the kid might dream at night that they have a blue cat suddenly. So the brain would kind of try to change color to just kind of try different possibilities, if you could say that.
Yeah, exactly. And like this, this input that is really like out of place, sort of, that is really bizarre and not fitting to exactly what you have done or experienced, is a way to reduce overfitting and to generalize better. Also in machine learning, so like having really sparse input that is really out there, so to say, that is really like not fitting to the general pattern, also reduces overfitting. So that is an interesting analogy.
Yeah. We moved quite a bit into memory formation in dreams right now, but that was not the actual topic of your bachelor's thesis. You did a study where you first presented the participants with pictures. I think they were all quite negative pictures, right? There was no pleasant
half of them negative, half of them neutral, actually.
What is a negative picture and what is a neutral picture?
Good question. So I used a standardized data set from some researchers in Poland. In my specific sample, our negative pictures showed like dead animals, car accidents, but not that explicit, so not like, I don't know, lots of blood and corpses or anything like that. Luckily not, but rather, like negative scenes, people that are sad or homeless or are hurt.
So quite pictures where everyone can relate and kind of when they see it might, with a little empathy, be able to kind of make up how a person experiencing this scene might feel. For example, when you have a car crash, that's really troubling emotionally.
Exactly. Like the negativity of that picture, so to say, is like was like standardized by presenting these pictures to lots of people, basically, and then assessing their emotional reaction. And then you have certain numbers. And of course, that's kind of subjective because I also like had some pictures that were not rated that negatively. And I was like, really, that's very disturbing to me. So, it's individual, but we try to vary the themes, so to say, like the things that were presented. So we didn't like choose only dead animals, but also other things.
Short question here again. Was one person only presented with one picture or with several pictures of the negative kind?
We had the pictures transformed into a video. So I made videos with 12 pictures each. And each picture was present for 5 seconds. And then you had 1.5 seconds black screen between the pictures. And then the next picture showed up. So each video lasted 1 minute, 18 seconds, I think. And we had 3 negative videos and 3 neutral videos. The order of the pictures was the same in each video. But the order of the videos, we randomized between persons, but we always kept the order of first having a neutral set of pictures, then having a negative, and then alternating. So always like a negative follows a neutral video and so on. But the specific order was randomized.
Okay, and neutral pictures were, for example?
Mainly landscapes, actually, and also objects like just a plain mug on a table or a plain chair. But actually mostly landscapes.
Okay, yeah.
And then after the people did the nap, what is the thing that you measure the next day or like after the sleep?
So we presented them with these pictures before the nap, then after the nap again. The pictures were the same, but the order was different because it was each randomized. And then we measured their subjective reaction with a scale, with the SAM, the self-assessment mannequin, which just shows like a mannequin. That is like first for the emotional tone of the picture, it's like has a sad face to happy face on a scale, and for the arousal associated with the emotion, it was like from only little arousing to very arousing. So that was like kind of shown with something exploding in the chest for really high arousal. That's just the picture scale, but many researchers use it because it's nonverbal and easy to use. And then the next days, so actually our experiment spent over 3 days. And the next 2 days after the experiment, we sent our participants a questionnaire in the evening asking about spontaneous memories of the pictures they saw in the experiment, their approximate number and duration, and associated emotional reaction with the same scale. So that is how we differentiated short-term reactivity to the pictures for before and after the nap, and then long-term emotion processing with looking at the number, duration, and intensity of the memories of the pictures.
And what did you find?
So luckily, I didn't have to do so much statistics. Also because we only did a pilot study with 10 participants, so our findings are not statistically significant either way because it's just a too small sample. And also my supervisor actually did like statistical analysis and just to see if actually something would be significant even if it's not due to the small sample size. She didn't find anything really that was really significant. But our most important finding was that people who didn't have dream recall had longer memories of the pictures the next 2 days. I think that's my main takeaway because we also followed a hypothesis which says that, or we followed a study quite closely in the design which found out that people that sleeping enhances the short-term reactivity to the emotional picture. So like the reaction is actually more negative after sleep or after the nap. But in the long term, people who slept had shorter memories of these pictures. So that kind of suggests that sleeping or dreaming and seeing the pictures maybe triggers some emotional processing that first enhances the negative reaction, but then in the long term reduces the memory. So you kind of dealt with it and are then like better off in the long run. And actually, like we didn't find the more negative short-term reaction, but we did find that people without dream recall had longer and more memories of the pictures.
So when you put it in different terms, you could say that after seeing something that was emotionally challenging, you first remember it more strongly. But when you dream of it, kind of the emotional intensity goes down.
Yes, you could say that, yeah.
Why do you think that people who could not recall their dreams not lower their emotional response?
Sorry.
When people did, you said that when people did not dream about, you said when people don't dream or they can't remember if they dreamt of the challenging thing, that their response did not go down compared to the people who did dream of it. Or did I misunderstand you?
We differentiated between dream recall and no dream recall first. So we had like two big groups. And then we had a further group division with the people who did recall their dreams into, they incorporated stimuli. So they incorporated pictures that were shown during the experiment into their dreams, and those who did not. And what I just mentioned was that there were not that, like the difference between like before and after the nap was not that high for any group. In fact, we did find that people without dream recall actually had like a more negative reaction both before and after the nap. But like the relative adaptation was not that high for any specific group. And the people without dream recall, so we don't know like if they dreamt of the stimuli or not, but they just had no dream recall, had longer picture memories the next days than the people with dream recall. But the people with dream recall are, there were two that just had some dream not related to the picture, and two who actually incorporated the stimuli from the experiment into their dream.
Okay, yeah.
We always try to put the episode into the broader context of cognitive science. And from what I've heard so far, I would assume that like maybe the main fields of cognitive science that are concerned with this research should be neuroscience and probably psychology. Would you agree to that? Are there more fields that are involved in this?
No, I would agree. Yeah.
And when people listen to this episode, is there any kind of take-home message they should remember? So, how would you summarize the interview and the whole topic?
I would like to people to take away that there is really a great potential in dreaming for your personal mental health. I mean, there's definitely more research to be done here, and that's maybe also a takeaway. Like, if you're interested in this kind of research, please go for it, or like, please spread the word, because really dreams are not that well researched at all. I would just say that dreams are not like mere, I don't know, side products. That's actually also a theory by some researchers that dreaming is just a side product of some other brain processes, and that we can't really have, or we don't really have a benefit at all from dreaming. But my take is that we do have a benefit from dreaming, and that is mainly, that, I don't know, emotions that are challenging or experiences that are challenging in our life can be seen from a different perspective during dreams, and are also like more abstract during dreams, and that probably helps our emotional life in the long term. And so pay attention to your dreams. If you would like to dream more, try dream journaling in whatever way. As I said, the success rates are really high. If you really try to do that as often as possible, as often as you remember something of your dream reports will get longer. And I think that's my main takeaway. And also that dream research is not just psychoanalysis, because actually, like, surprisingly often when I told people about my research, they were immediately like, "Oh, so you're doing something with dreams? So are you like looking at Freud or something? Like, are you looking at psychoanalysis? Like, what symbols do appear in your dreams and stuff like that?" And I was like, really, no, that's actually not what I do at all. I mean, dream research is really more than that, and also more than just the psychological side of it, but also the neuroscientific side of it. More researchers are looking at what really happens in your brain, why you dream, and how that is, benefiting your learning processes in general.
Thank you very much for your time, for taking us into your topic and into your research, and being here today.
Sure, yeah. Thank you for having me.
Before we roll the credits, we'd like to inform you about the Coxie Space Day. This is an event happening on the 18th of November 2023. On the Coxie Space Day, you can meet us as the makers of the podcast, but also connect to other fellow cognitive science students and alumni. There will be a lot of different booths, fun workshops, and some exciting surprises. The Coxie Space Day will be the perfect spot to get in touch, connect, and find orientation in the whole universe of possibilities in cognitive science. You can register on www.coxiespace.de, that's COGSCISPACE.de. We hope to see you there. When you enjoy listening to us, the best way to support us is by following us on your chosen podcast app. This could either be Google Podcast, Spotify, or Apple Podcast. Another good way to support us is by following our Instagram account, which is called kaleidoscience_pod. On our Instagram account, you will also get regular information on the next episode. Thanks a lot for supporting us. This was Kaleidoscience, hosted by Elisa Palme and Sönke Löw, produced by Alina Ohnesorge, Elisa Palme, Sönke Löw, and Sophie Kühne, produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science.